you the raw edit, and you can do what you need to do.
Right.
So it's just everybody, we are recording this. The recording will be available on the private YouTube that we always do. It won't be, well, if you're going to put it on your YouTube, John, is that going to be publicly shared then?
Yeah, that'll be public.
Oh, okay. Yeah, so it'll be public out there, just be aware. So if you don't want to have your name and likeness on here, then yeah. Anyway, I think we're okay with that though, because we're all pretty much on this side of the camera for a lot of things we do. Our online presence fairly well known. So all right, with that. All right, so let's go ahead and get going, John. Today, as I mentioned, we're going to be talking about OPC. It's my contention that there's a lot of misunderstanding about what OPC is and what it isn't. I think 99% of the controls universe, when they think OPC, they think that's my KEP server. That's how I'm talking to my PLCs and getting it into my SCADA system, regardless of whether I'm using Ignition or Aviva or iFix, GE's product, or any of the other number of products that are out there. But OPC does a lot more. And sometimes that's its Achilles heels, that maybe it tries to do too much. So I think we're just going to explore a little bit about OPC, and John Rinaldi, I guess, fire it off.
So let me get share. Let me share.
And while you're doing that, does anybody have any specific topics or content that we should be sure to cover in this session? And Matt Paris, you're not allowed to comment here, I'm just going to say.
I was simply going to start with a simple question of what is OPC?
Yeah. Oh, can you see my screen? Is it coming through?
Not yet. But I see you and Kevin got the memo about the orange shirt today. I merely missed that.
I never know if I should share the window or the screen. I always forget which one works better.
I generally share the screen, because then if I need to show something else, I don't have to stop sharing. The downside of that is that if there's something like a little banner that pops up, then.
How about now? Do you see anything now?
Sure can.
Okay, so this is a presentation that I have done lots and lots and lots of times. All right, so you can see my screen and we get started. Okay.
Yep.
So I've been involved with OPC since 2011. I found it in 2011 and thought that this was revolutionary. And so I've given this sort of presentation in some of these slides now for the last almost 13, 14 years. So some of this is a little bit, some of it's dated, some of it's not. But I'll just take you through kind of what I think. So this, what I start with generally is for less educated groups is the whole industry. We're industry 4.0. We don't need to do that here. So, and then I go through all of the different industries that changes. When I'm giving this to non-groups to talk about all the things that have happened and how manufacturing has kind of been behind the times, because things work a lot slower in our industry than they tend to work in all these other industries, but the same kinds of things are happening. And one of the nice things I talked about is how, the rate of change is really interesting to me because I'm in the communications, I've been doing manufacturing communications, and I started out with serial, and then after quite a few years went to Ethernet, and after quite a few years there was DeviceNet was first, CAN, and then with DeviceNet. Then there was 5 years before Ethernet IP came out. So it seemed to me that in the past we had a number of years to absorb things. That there was only one really big thing happen. Now it seems like we're getting massive new things almost on a weekly basis, if not sometimes a daily basis. So the rate of change is certainly just increasing tremendously. So what is the OPC UA? What's their vision? And you have to remember these are German folks, and the Germans like to do. They make broad, big standards that do lots of things. So their vision for OPC UA was everything. We would, so we're talking now. So we're talking about early in the middle 2000s, and they wanted to connect everything from chips to tablets to enterprise PLCs. Everything and anything was going to be OPC. OPC UA was going to conquer the world. So that was complete interoperability of everything. So the questions I want to answer today is, what is OPC UA, OPC and OPC UA? So we're going to go back in time and talk about where OPC came from. Talk about what the benefits are, at least what OPC UA, the OPC Foundation claims they are, how it works. I'll go through the technology, with the addressing model and all the different communications model and all of that works. How it integrates, and a little bit about where it is today, and then a couple of slides about me and RTA. So let's talk about OPC. So this is a long time ago when Windows first came out. There was a thing called OLE, Object Linking and Embedding, and that was the way that you could communicate between processes in a Windows computer. And they used to call it so OPC used to mean OLE for process control, but they got away from that. So when we talk about OPC, or even there was lots of different standards. Most people use OPC DA, which means OPC data access, but there's the alarm and event standards, there's the batch standard. There was a ton of different standards and different ways to implement, and they're different. Most 95% of people use the OPC DA standard, and that's really what was popular. Now, here's the time before that, when Windows first came out and people wanted to connect from a new Windows PC to pumps and PLCs and things. People wrote drivers, and system integrators actually loved this because they could get paid at every time they did an integration to write a new driver to the pump or to the valve or whatever the hell it was. They got paid for writing drivers, and so they made a lot of money. But it was very time consuming. It was very costly to do all that. It's very error prone, and if you weren't around at the time of Windows 2.1 and Windows 3 and all those things, it was those machines were not all that stable. So it was very difficult. So the idea was to get rid of this problem of having this very time consuming, costly effort, and create a way to simplify all this, and that was what OPC was. So before that, if you had 3 applications inside a PC, you would integrate a separate driver into each application. With OPC, you could get away from that. You could just put in the OPC driver for that device, and then the applications could talk to it over this OLE, which became COM technology. So that was phenomenal. All you could do is just buy these drivers, and this is where Kepware got started. So I can tell you a little story about that. In 1990, approximately 1890, 89, 90, I was presented with the idea of getting into the OPC driver business, and I said, no, I don't want to do that. I like doing embedded programming on microprocessors. I don't want to work in programming the PC. And then I saw that they sold Kepware for $150 million. So it turns out that I really made a bad mistake by not getting into the OPC business. But there was with the OPC, there was a lot less troubleshooting. You could really implement these things faster. There was better communication. It delivered a lot more value. So OPC really filled a niche at that time. And here's, so the way it worked is each application would have a COM interface. The COM interface would talk on internally in the Microsoft network within the PC, and the COM interface the driver would have the same COM interface. It would have the proprietary driver. That's the thing that actually knew how that device worked, and so that would be the code. It would take the data, turn it into OPC data. That would be on the COM interface, and any one of those applications then could browse that data and pick off and say, oh, I want this speed. I want to know if this valve is open or closed. I want to turn the pump on or off. And you could send data back and forth over this. So it worked out. It was a much simpler, better, faster, easier thing. So OPC was incredibly popular. As you can see, Kepware did very, very well with it. So the main features of this is, as I said, browse to see the data. You could get data on schedule by or exception. The data was timestamped, formed groups, and there was a quality indicator. Now that's kind of an interesting thing. So the quality indicator, because remember we're talking mostly at that time about serial communications, RS-485. A lot of devices were on Modbus. You could get a Kepware Modbus driver and talk to things. So you could have upsets on those networks. As RS-485, you could have some you CRC, and some of those things could be bad, and the quality indicator would tell you whether you could trust that or not. So that quality indicator in the era of Ethernet is pretty much gone away, because either you can read the tag or you can't read the tag. There's generally not a indicator that the data is suspect. So, and we also have
yeah, could you talk a little bit more about the get data on scheduler by exception? Because I think most of the time there's just a 1 second scan, and it's always this pull response. Could you comment a little bit more about that get data by exception? What does that mean?
Well, that means that you could get data on change, report by exception. So if you could set it up so that it would publish the data when something changed.
I see. Okay. So it's continuing to scan. It's just only going to publish it to something else. So if I'm subscribed to it, I'm only going to get that when something changes, not.
Yeah.
Okay.
That's
just making sure I understand.
We're talking about technology from almost 30 years ago, Dave. So I'm pretty sure that it's a little bit fuzzier to me now than it was back then. But as I recall, there was a way to set it up so that you could so that the data would come to you when it changed. Okay.
Yeah, we joke at my house about, well, that was in the 90s, and the kids already understand that's code for I really don't remember that.
Yeah. So we're talking about stuff from a pretty long time ago now. The limit that, but there are big limitations to OPC. Only one platform, Windows. It didn't work on Linux, didn't work on anything else. And Microsoft pretty quickly obsoleted COM and DCOM. In fact, it's been obsolete now, I think, for 20 years. It's still included. I'm fairly certain it's still included in all of the new Windows versions, but it is obsolete. The security was really bad. Interesting thing about the security was that typically when a Windows PC got these things were all very what do you say, fragile. It would be the word. So if there was a Windows update that happened, there would be a reboot, and now the OPC driver didn't work, the system didn't work. The first thing that someone would do would come in and turn the security off and reboot the computer, and then everything would work. So they'd leave the security off. So security was almost non-existent in those days. Data typing was very limited. There was very few data types. There were all these different specifications. They were all separate. So I think, as I recall, that if you were going to use the historian, that would be almost completely different than using data access. And there was no data modeling. You got pieces of data, and that was it. So it was very limited. So OPC UA came in and changed a lot, and that kind of came to try to make this a lot better. So it went from a driver replacement to a system interface that you got object models now instead of just data. You got the platforms are expanded to anything. Security became a lot more comprehensive, and then with the OPC, you really couldn't talk stuff across the internet. There were some bastardized ways to do it, but generally you could do it on a local network using the Microsoft DCOM, but there was no way to go across an internet interface. So OPC UA was the thing that came to fix all these things. So OPC Classic, the old one, was really just really low in the architecture. OPC Classic was expanded over time to get up to cover all of manufacturing. And the idea for OPC UA is you could do absolutely everything with OPC UA. So their vision has always been very large, going from islands of automation and covering absolutely everything, including multiple plants, so that you could connect multiple plants up on OPC UA. it was everything. It was every application to cover every application to do everything. And it's still pretty much that's their motto today. I don't know. And because last time I went to the OPC UA presentation at I think it was at ARC, they put OPC UA in a rocket. So they're very proud. I think it's in one of Elon Musk's rockets. So what is an OPC UA? So this is a industrial connectivity architecture. It's much more than a protocol. So it's got a sophisticated information model, and this stuff, I thought when I first discovered this, I had never heard of this kind of stuff. So this is in 2011, and nobody was talking about this kind of stuff. It was completely new to me, and I was just blown away by how incredible this was. Information model, a messaging model, a communication model, security model, conformance model. They separated all this stuff, and the idea was that over time, if you had a better way to message things, you could just replace that part with that better message. If you came up with a security model in 10 years was totally different, there's a better way to do security, you could just replace the security model. So all this stuff was supposed to be distinct pieces that could be replaced. And the big thing we want to emphasize is that this is an architecture, that it's not just a protocol. So there's much more here than just sending bits on a wire. There's a whole lot of other stuff in OPC UA. So, and this slide is in there for my, when I do this for control engineers, because they said, let's just use Ethernet or IP or Profinet. Why not those things? But those things aren't anywhere near what OPC UA is. Okay, so as I said, all of these things are somewhat distinct. You got, and it's a client server architecture. So this basically started out as request response, but of course, request response wasn't good enough in the future. And besides being client service, that you could implement it using any of the technologies, .NET, Java, C++, whatever way you want to implement this, you could implement it. So it wasn't really, the platform wasn't at all defined. It was really an completely open platform, and being able to replace these pieces as you needed to solve some kind of application problem, I thought was pretty cool. So the benefits that the foundation talk about is unites all these specifications. With OPC, you had all separate specifications. All of this is you have all of that same functionality in UA, but it is coalesced into a single specification. Now, that doesn't mean to say that people are using that stuff. In my experience, I've never heard of anybody really using the historian piece, for example. Alarms, possibly there's people using alarms, but I don't know, they are or not. But so there's a lot of, one of my opinions is that they've tried to do too much with this, and they have a lot. It's just like your iPhone. There's 95% of stuff that you don't touch. You just use 5% of it. Same kind of thing here. A lot more there than anybody's really using. The second benefit they talk about, and I mentioned, is platform independence. I don't need to dwell on much of this. You have to remember when OPC was still there, when OPC and OPC UA came out, we still had low resource kinds of devices. It's only been in the last, 5 years that everything has a really fast processor in it. Everything has a ton of memory. Everything has 4 Ethernet ports. We were still talking in those days when this was being thought about. We were talking about small embedded controllers that had a little bit of memory, and that's kind of my background, because my first application was for a converting machine in Kimberly-Clark. I had 2K of flash and 64 bytes of RAM, and I knew every single byte of RAM. I could reuse byte 54 over here because I knew it was only used over there for a little bit. So it was designed to operate on very small systems all the way up to very big systems. it was designed with really good security. So then they've put a lot of effort into that. And I'm not going to go deep into the security thing, but they had the security's been analyzed. They promote this all the time. BSI, that's the Federal Office for Information Security in Germany, that's constantly studying this and making sure and telling them that this is, phenomenal security and it's really good and all that. So they evaluated it. It's very, you have to say it's been tested and it's been able to do thousands of points per second. It does recovery communication loss. It's got keep alive. It's got all the kinds of things on the low communications end, the transports that you would want in a system. The object model is pretty cool, and we'll talk about this more in some upcoming slides. There's the objects are composed of variables, events, and methods. So everything is an object. An object is the smallest piece of the information model is an object, and objects link to other objects, and that's how you form hierarchies in OPC UA. It's object based. The data model is pretty sophisticated too. You can things of pretty much anything, because they have very specific ways of doing these drawings where you can draw out how everything is interconnected, because you see all the arrows have different or have some different types of notations here. Well, maybe not on this slide, but there's all these everything links to everything else. Objects link to other kinds of objects, and there's a lot of typing, and we'll talk about typing in a second. But this is very sophisticated way of doing modeling. There's methods, so you can do program invocations. You can start and stop pumps and do things like that. That's in there using method calls. So they claim it's architected for speed and performance. You can use binary. You can use binary if you really want high speed. There's lots of different ways to do things because it's very complex. And then they claim that it's great. You can vertically integrate it, so you can work at the plant network, the operations network, the enterprise network. So those are the 10 benefits that the OPC Foundation claims for this thing. So let's look at this. And then in Germany, OPC UA really dominates in Germany, because in Germany, everybody gets together, the industry, education, and industry, to decide which way they're going to go, and they've decided they're going to use OPC UA. So they use OPC UA for pretty much everything in Germany. All right, so some opinions from me. Number one, I think the complexities of I like some of the complexity. It's just a little too complex. There's too many. The spec is too big. There's too many different standards that people really don't use. So they're over the top on complexity. It's still best for resource-rich devices. You can't really put this on anything that doesn't have a lot of memory and a lot of speed. The argument I have for this is that when you take a technology like this and you try to solve every problem, it really doesn't solve any problem. It's pretty much true of any technology, and I think of this, it's true because, somebody asked me, what's OPC UA good for? I said, well, what do you want it to do? It can do it. So the publisher subscriber thing is really interesting. So they started out, as you saw in the previous slide, that everything was request response. Well, obviously that doesn't work very well. So they added very quickly in someplace around the middle 2000 teens, they added publisher subscriber. The problem with the publisher subscriber that they added was that if you had a speed and you wanted to be published out to 15 different devices, it could not be published to 15 devices. You'd have to do a separate subscription. You'd have to have 15 subscriptions, and the device would have 15 copies of that interface in order to do that. So if you were going out to 1,000 different places, you'd have to have 1,000 copies of that. So that didn't work very well. And they were trying to compete with MQTT, so they started this effort to create a pub sub. Now the pub sub thing got done, and it's kind of unwieldy, and as far as I know, almost nobody's been using it, and that's there, so they've, I think, have realized that MQTT is a better option for sending data to lots of different places than the mechanisms that are built into OPC UA. We had one of our engineers was on the team that was working with PubSub, and his comment to me was it's all IT people that really don't understand manufacturing. Yeah, it's overly complex. How you manage certificates on the factory floors, I still don't have a good understanding of how people want to do that. So that's a problem too. Let's go through the technology a little bit now. So the base unit of a base unit of data in OPC UA is an object. So the object's composed of three things: variables, methods, and events. So what you can do is there's, of course, read-write operations on those variables. There's publish requests, so you can say, I want to publish this variable. I want essentially a subscription. I'm subscribing to this. Publish it to me every 30 seconds or every time it changes, whatever it is. There's method requests that I want you to start the pump. I want you to stop the pump, run this thing. And there's events associated with the object. So when there's a state change, this is the event we want to happen. So the base unit is this object, and objects can now, as I showed before, can be referenced to other objects. So you can have lots and lots of these connected in any way, shape, or form. So this is the object model within OPC UA, is having all these objects connected. It's organized in a pretty slick way. So everything, there's a root object in every OPC UA server. Then there's a organizer's reference from that root object that goes to a number of different folders. I only show 3 here. The base one would be the one that everybody wants to go to is the objects folder. So that has the specific objects that are within this system. So this is an example of the objects for a curing oven. So first of all, there's a type definition. Everything is in OPC UA is typed. So there's an object type curing oven. So that object curing oven is a member of an instance of that type. It has a number of, coming with it, it has a number of components, and I show 3 examples. You could have a timer component, a heater component, and conveyor component. Each of those, of course, can have components under them. So this can essentially go on forever. Then there's a method associated with the heater object. There are variables. When you have variables, this is where we have the different notations to describe different things. So the variables, you have variables underneath objects. Those variables can also be typed and come from a type definition, and you're free to make your own type division if you want. There's also properties associated with these variables. So property is just another kind of variable that is related through the has property reference. So you can do pretty sophisticated object models with this. And this is the organization that really is in every OPC UA server. The typing is I think is really cool because you can type at every level. So you can type to a variable, you can type to a whole object or a whole group of objects, and you can create your own types, or there's types from the foundation. There's types that trade groups are doing. We'll talk about that in a second. There's types that vendors can do their types too. And then there's meta descriptions associated with all this. And uses form hierarchies from this and use these types. So it's pretty flexible, and it's pretty sophisticated. So here's some more on the typing. You have a couple of objects. The objects have their type. There's a base. The reason for this slide is there's a slide in the ref. There's a base reference type. So everything operates off a base type. So if you're going to create a pump object, there would be the pump object type is an instance of the base reference type. So, and you have type definitions links to each of these things. And so it shows components, and this shows some variables that have their type definitions and whatnot. So it's pretty. I was just, when I first found this, I thought this was just unbelievably cool. Now that's what the object model. Now let's talk about how this is implemented in the address space. So the implementation is by nodes. So everything in OPC UA it starts with a node. So that's the implementation structure. So the node has two parts. It has a set of attributes and it has a set of references. And we've seen how references work, so that, references, that's how you reference from one node to the other node. The relationships can be internal, external. There's essentially you can think of references are like pointers. And it's meant to be browsable so that if you start at the root node, you can go all the way down and go through the whole address space by following all these references. The base characteristics of attributes are inherited from the type nodes. The attributes are common to all nodes. Now attributes are actually fixed. So this is kind of interesting. So every node can have one of 21 attributes, and it has one of these, and the node class attribute 2 identifies what kind of object it is. So node class variable, if it's a variable, it's a 2. It says that this node's a method. This says it's a reference type. The type, data type, it can be, so this says what kind of type, if it's a type or it's an actual working node. And then the references are, here's the type pointer, the type division, here's a subtype, here's a component of this, here's a property. It has a property here, this and that. So everything works on these node IDs, and because everything is fixed, it's relatively easy to handle in code, and users cannot modify this. So this is all fixed and unmodifiable. So the node hierarchy is that there's, of course, a base node, and the base node is connected to all of these different objects for the particular system, the method and the view, and I'll talk about that in a second. So, and you can create this, and you can go into essentially a tool. You can see how if you have a particular object type and all of the structure, you could pull up all of the details by following through this structure. Working on this address space, you have a number of services that work against the address space. And then I got 6 basic services here that we'll talk just a little bit about. View services limit the view so that you could have devices that can only see parts of the address space, or you could see, so you could, I just want to subscribe to everything within this view, and I can publish within the view. So you can essentially limits the portion of the address space that you're dealing with. Event services are for creating and installing events. And so you can set up all kinds of, all of that kind of stuff to say, I want to publish data when the pump starts or pump stops or all that kind of stuff. The discovery services, now this I thought was really interesting, because it's always hard to know, how am I going to find a particular device in a network? So some of the things that they did, they said that every OPC UA device has to support the same endpoint for discovery. And the discovery endpoint has limited services. Essentially, you go to the discovery endpoint, and you can say things like, who are you? What do you support? What OPC UA profile do you support? So that's pretty, so you have a place to go to learn about the device. And of course users can turn that off if they don't want it to be discoverable. You can automatically find servers. So they have essentially catalogs for loading all of the servers into it, so it makes it easier to discover. So one of them is called the local discovery service. If you use the local discovery servers, an OPC UA server that's in a device can register with the LDS. So here in this PC, there's 2 servers. Both can register with the LDS. These clients then can go to the LDS and say, what servers do you have available? Oh, we have this one and this one. And then they can go to once they know that, then they can go to the server and say, and discover what do you support in your, and how do I access you? Can I access you? And what kind of authorization do I need to access you? So the LDS is running on a defined port, 4840. So, but you still have to know where these things are on that. So on top of that, there's also a global discovery server. So the global discovery server is the place where you bring that talks to all the LDS things, register with the global discovery server. So the clients can go to the global discovery server and essentially see a list of all of the possible OPC UA servers that they can talk to. And that's the place which manages all the certificates too. And it manages and updates and does all the certificate handling. So now, as I recall, I haven't really been in the market for this, but for lots and lots of years there was no GDS. I remember 5-6 years ago that somebody was working on building a GDS, but mostly, mostly this is the idea. Is the GDS and the LDS is all the idea, and some of it, the LDS I know has been implemented. Mostly though, people just do it the old-fashioned way. Hey, the server's out there at 192.168.1.100, and they don't use all of these directories. I don't think.
Yeah, I don't know that I've ever run across a GDS. We're typically just working right with like I said, it's the OPC server that's connected to the PLCs that I'm going to be working with.
That's
OPC.
Yeah, exactly. So this is so the idea is that there's so much more functionality, as I was talking about with the iPhone, right? I mean, it's 95% of the stuff here is not used. Security, it started out with different levels of OPC UA, that there would be a nano, which have this much functionality, the micro have a little more, they better have more, because it was designed with the idea that there were various levels of devices that have various level of resources. And they came up with the idea of a conformance unit. A conformance unit is a small functional component of a server that could be independently tested. And so if you were going to use an OPC UA server, you'd have to pick the conformance units that you wanted to support in that. Certification, and now they've gone back and forth on certification. For a while, certification was absolutely required. Then they said, well, certification is not required. Anybody can use it, so you can't. Or certification's optional. So I think it's still optional. I don't think you need to be certified. This is a trade association. There's some trade associations that have really jumped on this. The biggest one, I think this is the underwater drilling system, or what, trade association or something. What's fascinating about this is imagine the cost it takes to build this thing, to staff it with people, drag it all the way out to the North Sea and put it there. But the biggest cost of getting that thing out there and functional is the system integration. So this trade association decided that to lower that cost, we are going to require absolutely every piece of equipment on this drilling rig to support OPC UA. because we got to get, we can't live with the kind of costs we have for integration, for integration.
Yeah, most of the companion specs that I've run across are very specific to oil and gas.
Yeah,
And when you
right.
think about a refinery, every refinery does the exact same thing. They bring in some crude oil assay and then they process it and make some defined end product. And the processes that are there are very well known, whether it's something they do internally or there's a licensor like what is it, UOP out of Des Plaines, Illinois. They all have it's the same type of data that's going back and forth. So it's
Yeah.
very easy. There's not a lot of variance in the type of equipment you're going to see. So I've seen it there. To me, it makes a ton of sense. I think we see this especially when we get into data modeling and the like. So
yeah, I agree with that. This makes a lot of sense here. And in these kinds of systems that are massively big, the system integration costs are so high. You've got having a standard makes so much sense. Plus the fact if you don't have a lot of variance, even better. So there's all kinds of companion specs. I mean, they're always talking about the hundreds of companion specs that they have. Except for the oil and gas ones, very few of the other ones are actually implemented. So nobody really, I don't see a lot of people implementing those things.
yeah.
No one's ever asked us to implement a companion spec.
Yeah, I think in our view of the world, I don't know that any of us really do too much work in oil and gas. But one of them that's pretty common is MT Connect. And there was a comment that was made in one of these sessions that we have that even within MT Connect, you can have two things that support it and don't actually talk to each other very well because they've implemented different parts of that MT Connect companion spec, which was that was eye-opening to us. It's unfortunate. I mean, what we're seeing now is it's the data models of being able to integrate things very quickly that I just connect to the network and I'm now immediately everybody else knows, oh yeah, you're this thing. I mean, we all love that idea. We're just not there yet.
Oh, you get there with MT Connect. If there's nobody that can enforce a certification process to say you have to support X, Y, and Z, then you end up with that each vendor's still doing some. They're using a standard, but they're using it. They're using it with specific pieces that they want to use, and not other pieces that the next vendor is using. So we don't really end up in a better place when that happens.
Yeah, and I think that's been some of the, when we get to this, oftentimes the argument you'll hear it's this OPC versus say Sparkplug in this case. And Sparkplug is great. It's an open standard. I connected, and as long as I can support Sparkplug, I'm going to be able to read the data. And there's a template that comes across it, but I might have one pump vendor that does their Sparkplug model, a second pump vendor that does their Sparkplug model. I can communicate with both of them and I can read all the tags, but they might have a very different tag structure. So it really doesn't give me an interoperability the way that I would hope to be. And I think SESME is trying to go after that and solve that. But I think there's 5 people in my family and sometimes we struggle on where to go to dinner. So I mean, we'll starve before we actually make that decision sometimes. So I don't know how we're going to be able to align on all that. But, anyway, that's what I've run across.
That typically in the past, everybody just aligned to what Allen Bradley and Siemens did. Now it's kind of the wild. That's the wild west. It's more wild west now. People doing
exactly now we have all these Zoomers out there. Like nobody's going to tell me what to do. Fight the power, and if Rockwell says X, I'm going to do Y just because.
Yeah, and that's the advantage the Germans have is that they're very used to a central authority who tells them what to do, and they all get together and decide. And once the decision's made, they all live with it. There's no cowboys in Germany. In America, we all think we have the better solution.
Yeah, which is usually why we hear from when I talk to Germany, like, God, what do these stupid Americans want now?
Yeah, right. When you implement, people come to me and say, I want an OPC UA server. Well, what does that, what does that mean? What transport do you have? What kind of security you want? Do you want the discovery services? What encodings? I mean, there's a million questions you can ask about implementing an OPC UA server. So these are all the kinds of things that make things somewhat incompatible. The companion spec supposedly, help this a little bit, but not many people are using the companion spec. So it's really, you get the object model, you browse the object model, find the data that you want, and you pull that, and then you say, hey, publish that data. I want to subscribe to that piece of data.
Yeah, but going back to that slide, John, when you think about the, having a method that I can operate something on. So if I have an endpoint where I want to instantiate a method, having that's pretty nice, because I just want to be able to send, make, say, an API call in another context that I can, here's the method I'm going to publish to this endpoint. Here is the model that you've defined of, send me this data, and now I can do something with it. That to me is pretty powerful, that I have that built in, that if I can expose a method, now it gives me some ability to do some things, or even just some metadata that's in it. And strong typing is not all bad. So, to me, there are some things here that are really very, very cool. But I think it's, to your point here, I think it's important to understand that, yeah, there's a lot of things that it can do. What do you want it to do? But then of those things, that these are the things that I would highly consider.
Is the complexity in implementing, or the difficulty in implementing, because you have to execute many of these capabilities, or because you just have so many options?
Both. Yeah.
Okay.
Yeah. Both of those things. There's lots of different options that you can have, and there's a lot of code to implement, and it's there's a lot of pieces, and people there's great flexibility here, but flexibility always leads to complexity, right? I mean, Modbus is not complex because it's very fixed in what you're going to do. You have registers and you have coils. There's no, that's why Modbus is going to live forever, because it's not complex.
And this kind of lots of options, lots of flexibility creates a very complex tool to create then results in different companies implementing them in different ways, and then to connect to two different OPC UA servers is different.
Yeah.
And it's
yes, if you get two pumps with OPC UA servers from two different vendors, there's little chance that you're going to have to, there are two different implementations, because you're going to have to browse this one, you're going to find the pump speed in a different place with a different name than over here, and then on the other one. So essentially all that, we've accomplished is we've got a nice tool for getting the data, but you still don't have that context that you really would like to have.
Yeah, that's what we see, and I'm validating where that's coming from. So that makes more sense.
Right, and who's there to say, well, unless the customer is going to say, here's the model I want you guys to implement. I want this address model with these nodes in your pump, or I won't buy it. But I don't think there's many customers that are sophisticated enough to demand that. The place where that's.
Go ahead, John.
No, you go ahead.
Yeah, I was just saying, I mean, so I was, the example I was going to give is that I'm working with it's a German company that they make plastic extrusion equipment, and it's very good equipment. And I think the challenge comes more from the experience, and I don't think it's a fault of OPC, but there was a method that was exposed to get some alarm events off of it, but they hadn't fully baked it out. So from, the customer experience side is, you have this method, it's in your documentation. I tried to use it, which wasn't easy, and I'm not getting the information out. I could use your internal tool because I had the things that made it work inside my tool, but I couldn't use an external tool that supported OPC UA to get at it. And that was the frustration that we ran into. And it just made it such a challenge. And again, it wasn't the fault wasn't with the OPC standard, it was in the implementation of the standard. And I think it's a very subtle but very powerful difference. And I think it's the user experience where the challenge comes from, not the technology itself.
Right, exactly. The technology is very, very flexible and it can do all that, but it has to be implemented properly, and it has to be implemented equivalently across certain devices. And that was the idea of that's the idea that Sesame has, is make all this stuff that's just like printers, right? Make the same printer driver, that you just get a printer driver and it's just going to work, because they're essentially very similar. Similar interfaces, because they do all the same kinds of things. I don't know that we'll ever get there in manufacturing.
Well, I think we're going to run into we're going to be able to do utilities. And when you think about Sesame, it's all around clean energy and smart manufacturing. And where you're going to find the clean energy, when you're on the utility side of any business, they're going to have an RO, they're going to have a chiller, they're going to have some evaporator. There's going to have those types of equipment that are largely going to be the same types of things. And I think you'll get there, but when you start getting into the manufacturing process itself, if you have some kind of web press, regardless of how you're using this web style manufacturing, whether you're doing film or tape or magnetic media, whatever it looks like, you can have two lines right next to each other in the same plant, and they're going to be very different just because they were, somebody else worked with them. I don't know that you'll ever have a standard for that.
Well, see, and I make that example too, because Kimberly-Clark has 75 diaper machines. They were not built the same day. I mean, you're building these from, this one is built 3 this year, 3 the next year, or whatever it is. I mean, and you have, all of a sudden, you've got different components with different capabilities on the newer machines that you'd had, the ones that were put in 10 years ago. I mean, how do you standardize that?
Yeah, so Wonderware system platform was light years ahead of what everybody else was doing. It was object oriented, and when it first came out, I think early 2000s, it was very powerful. But people didn't understand how to leverage its benefits. So, I've run into plants where you had 3 different galaxies in the same plant, and not one of them was the same. And it's like, I think you missed the point here, because those 2 machines were largely doing the same type of thing. And again, I think it just comes down to understanding what the technology can do and using it, and it comes back to the user experience. But that's that we run into that on so many different things of, man, this thing could do some amazing things if you just use the technology right. Don't put all your scripting on the button. Have a function that button calls, that it makes it easy to change what that button does centrally. And if you don't understand that within the technology, then it becomes a yeoman's task to change the function of that button that exists in 50 different places.
Yeah. So the problem that I have when people call us up and said, we're doing this device, we want an OPC UA server. Well, what does that mean? There's lots and lots of questions. So that's the summary of this slide.
Yeah, I just have them call Software Toolbox and just get a Kepware license, and we're good. Or OPC router, or Matricon.
Yeah. So they keep modifying this compliance. I don't know that the certification slide's up to date at all, because I lost track of what if they're requiring compliance and if it's optional or what. So it's
yeah.
So now
I got into
Microsoft
doing some self-signed certificates with OPC, and there's I'm trying to remember. I ran across I don't want to call it a tutorial, but of the types of things that you will need to include in it. So if you're familiar with doing your own certificates, there was a SAN address. There was some. I'm trying to think of some of the other characteristics or the other extension properties that you had to include with it, and they had to have a certain what is it, the way you went about implementing and everything, and for sometimes it worked and sometimes it didn't work, and I couldn't understand why. But anyway.
So who's behind? I mean, Microsoft has a huge commitment to OPC. So a lot of people are very unhappy with that Microsoft is on the board of directors. Eric Bernstad is on the technical advisory council. So Microsoft is deeply embedded in OPC, and and they're driving this technology. Now, one of the I always ask people, it seems there's two opinions. Some people say, well, OPC is hardly used at all in the United States, and other people say, no, well, it's used everywhere. I think the people that are doing Microsoft's kinds of projects with companies that are standardized on Microsoft, they see a lot more OPC, I think, than other people that are not using Microsoft stuff. But I really don't have a handle on how much OPC is really being used in the US. I know in Germany it's all over the place, but not so much here, because here Allen Bradley hasn't really been rushing to support OPC, though now they've committed to putting a server in their Logix PLCs at some point in the future.
Yeah, I think the word on the street that we run into a lot, and this goes just really to the cloud technologies, is that AWS, they start with the user experience and then build in the technology, versus Microsoft, they really have a robust partner network. And so they think about, how can we make this attractive to the partner network? And the user experience sometimes comes at a cost. And I'm not saying that that's true, but that's the general consensus, or what I like to call the conventional wisdom around these types of things. And sometimes it's I'm going to do certain things, like, and there was a patent that was awarded regarding a Microsoft and an OPC, and that struck the market a little strange. Of, okay,
Yeah,
we're trying to make all this open, connected, we'll work together and create these things, but meanwhile, I'm going to patent this just so I can have a little bit of control and say over how that used. That didn't sit well, but there it is.
I can echo that about AWS. I talked to a project a manager on an airplane one time, sat next to me from Amazon, and he said they start with the press release. The very first thing they do when they're going to come out a product is they put the press release together to announce, this is what we're doing for the users. I thought that was an outstanding way to start a project.
Yeah, they do that internally. In fact, I'm on a specific, it's called Reimagining Divisions within ISA, and we actually crafted a press release on, when we do this, should this happen, is there's going to be a press release that comes out with it. That also included some Q&A. And it took us a while to get this thing put together, because we really wanted to think through exactly how is this going to be perceived.
Yeah, that's right.
Which was a great exercise.
It is, and engineers like to start coding, but you really need to start and do that. And OPC is part of Azure. I would love to know, I don't know if anybody knows, how much MQTT is used here versus OPC UA. Probably, I would guess probably more MQTT, wouldn't you say, Dave?
There was a technical architecture that Eric Barnstedt put together. I'm trying to remember. I think it was around a digital twin, but don't quote me on that. I don't recall there being a pub sub piece to that. And when I say pub sub, I mean using I think it's part 14 of the standard that was MQTT. I believe it was OPC back and forth using the traditional, I want to call it the pull response, but I mean, there's been a lot of discussion back and forth of which one's more lightweight than the other. And I think it really just comes down to implementation, because I can make an MQTT payload. I can have a device publish an update every second, regardless of whether it changed or not, which makes it heavy, if you will.
Yeah. Yeah. So Beckhoff is also one of the, Beckhoff pays the salary of the director of OPC UA, so they're heavily involved in that. But they're a big Microsoft partner, always have been. Their PLCs have been Windows based forever, as far as I know. So that's another big partner for OPC UA. So my thought, this is kind of what I thought would happen. I was always in love with PACML. I thought PACML was a wonderful standard, and I thought, because if you're not familiar with PACML defined the operating states of a machine and created a user interface for machines that showed what all those states were, and specified a lot of that. So you could train an operator who knew how to operate a PAC-ML machine, and they could go from machine A to machine B to machine C. And if they were all PAC-ML machines, it would eliminate the training. I thought this was really going to take off at one point. Didn't.
Yeah, and I think it's because we got the, what is it, the 14 different states that it can be in, where I'm stopped, I'm starting, I'm started, I'm in execute or held, and that type of thing, but it never really advanced any further after that. So from a control standpoint, if you want to do your state machine based on PAC-ML, it's pretty powerful, but after that, you know, running is, okay, great, so I'm in execute.
Yeah,
Now
once you're
what?
next, yeah, that's all. The only thing that happened was execute. That's right. The TSN is another thing that seems to be seemed to be really hot for a while, and OPC UA was going to link the whole world with TSN. I don't hear any much more about that anymore either. Do you, Dave?
I see this mostly in high speed packaging. And I think going back to, you know, in process, so where you're going to see a lot of OPC UA, so I'm going to, you know, oil and gas, say refining or chemical, where there's a lot of defined processes, the data. I mean, even the API has a standard around data interface, data interchange. I don't remember the API standard. I think there's an equivalent ISO of it as well. So I'll see it there just because we need to we need to put a timestamp on it and understand when things occurred. But I think it's in pockets of where it makes sense.
This thing was supposed to be because it gave you determinism, but you know, as the network speeds get higher and higher, you get determinism by default. So it's kind of the summary of OPC UA. Here's the things I want you to take away with this. It's a successor to OPC. It's a whole architecture. It's not a protocol. There's different kinds of models: the messaging model, communications model, security, information, conformance, so all these different things. And these pieces can be interchanged and be swapped out for better ones. It's object-based, and it's implemented by nodes. It's traditionally client server with some publish subscribe capabilities that aren't that great. So that's kind of the conclusion of the OPC UA piece. And then I was going to talk about, you know, for 5 minutes about RTA, unless somebody wants to have the OPC UA question at this point.
Yeah, so I think, Matthew, you've been the most verbal around OPC, and I think this is a lot of your pushback on it is it's an architecture, not a protocol. And I think John echoed your sentiments of it tries to do everything and then it ends up doing nothing. So it's like if everything's a problem, nothing's a problem. It's the same type of thing. But certainly any comments you have would be awesome at this point, Matthew.
Yeah, I'm putting together a summary of points to release in an article coming up soon. But at the top of the list is it's called OPC UA, a unified architecture. And the question I would have for the foundation is where is that unified architecture shown on the webpage of OPC Foundation? I think that's a good question of how do they envision OPC UA being implemented. I think the only diagram I've actually seen is just a general schematic showing OPC UA going everywhere.
Yeah.
And it might be that we just haven't solved that problem yet, but we know we will when we get there. So just trust me. You know, it's whether there's an automation company, one of their taglines is consider it solved. You know, it's not solved, but just consider it solved. We'll get it.
Well, but part of that problem is if you show it going everywhere, then do even the architects of the unified architecture have an idea of how this is supposed to be implemented within the marketplace? And I think it goes back to that statement of it's too broad for it to actually come to reality. Like if you were to pick a simple use case of, I want to read inputs and outputs from a PLC in a standardized way. There's not even standardization there. And that's such a basic use case. So why has that, you know, and that's just one of a million use cases we face in industry. So if even the simple things are not being solved, I kind of wonder if what problem are we actually trying to solve?
So when I think about that, we can't solve the simple use cases. I mean, we run into this a lot where different controls engineers will use different tag naming conventions. I think this is one of the hardest parts of programming is, well, what am I going to name this thing? And I still just muse at that a lot when I'm just trying to write code for something. I'm running some script and it's like, what am I going to call this thing that it's going to equal the result of whatever it is that I'm trying to do? I mean, to be interesting, because I mean, one of the first standards that came out of ISA was around instrument objects when you're doing PIDs or PNIDs. I think it's ISA 5. And it's almost like, can't we just take those things and just decide, okay, this is now going to be how you're going to do tags for this type of equipment, and it's going to have these basics, and it's almost this is your core model. It has to, it shall have it to meet this standard, and you want to use this type of tag naming convention. I mean, I think that'd be pretty slick, but I don't know.
There was some group that was putting together a standard for naming conventions. Boy, I haven't heard about them forever. That was like 10 years ago to solve that problem, but
Yeah, I always go back to the XKCD, comic of, the current state is that there are 14 competing standards, and so in the middle frame it's we should come up with one standard to rule them all, and then the last frame is future state, there are now 15 competing standards, and it's so true. I mean, even with what is that, Margot, that just was announced here a couple of weeks ago. It's like, is this just yet another thing that we're going to do, and everybody's going to jump on board with it? It's going to be a great press release, and we're just going to run into the same challenges.
But don't worry, John. They announced at Hanover Messy that they're got a new working group for artificial intelligence for OPC UA. So I think.
Oh, great. That's what it needs. Yep, that's what it needs. It needs artificial intelligence.
Well, you have to have an AI because that's what shareholders want to see. Is you got to be an AI. It's the shiny thing, And it's like, I got to tell you, when I still see people using massive Excel spreadsheets, and our manufacturing state is all somebody's written on a whiteboard, or even writing things down. I mean, it's amazing, but we're going to do AI with all that manually entered data that may or may not exist anywhere but on a piece of paper.
Yeah. I remember going through a plant in Western Michigan, and the control room had maybe 14, 15 computers all along the wall, and each computer had the little Post-it note for that particular system, what the username and password was. Unbelievable. All right. Well, let me just finish up here with a little bit. So this is what the RTA office is. We have a 15,000 square foot facility. I got fired from Kimberly-Clark, and I suffered for 3 years at Allen Bradley before I started RTA. I've done a lot of writing. I've done books, and I got like 2 to 3 million views on YouTube for most of it Modbus stuff. We want to save the world from inaccessible data. Is kind of like, I got a story about where this came from. The president of Google at the time was down in there was a restroom. They had one big restroom for men and one big restroom for women at this Google building. And Dave, did I ever tell you this story?
I don't think so.
I don't think so. Okay. So the president of Google goes down because they wanted everybody to mingle at least once during the day. So they had just these big restrooms. So the president of Google is there, and there's a guy that's washing his hands. So the president of Google had to, felt kind of obligated to say hello. And he said, "So what do you do?" He didn't really want to know, but one of those. "So what do you do?" And the guy said, "I'm saving the world from Internet Explorer." Because he was working on the Chrome team. And then, and it was such a great way to present. Instead of saying, "My name is Jeff and I'm doing this, that," the other thing he said, "I'm saving the world from Internet Explorer." I thought that was such a great story that I spent the rest of the afternoon trying to figure out what I could save the world from. So I decided to save the world from inaccessible data. So that's what we do. So I've written a bunch of books. I've got a newsletter if anybody's interested. I got a pretty different newsletter, some personal articles, some technical articles, some fun stuff, and we deliver that in your physical mailbox or online if you want. And then
Yeah,
I also
it is the best damn newsletter out there.
and then also do on LinkedIn every 2 weeks. I do the myths, facts, and lies of smart manufacturing. Kind of an odd look on what I think about different topics of smart manufacturing. We have a bunch of core values that we really believe in. We actually fired 2 people now for not doing what's right. So we really believe this stuff. Simplicity is my goal. The thing on the left is an actual 50th anniversary Swiss Army knife. It has 129 different tools. And I say this is the typical automation product. This thing costs $1,200. It has all kinds of functionality. You could build a shopping center with it if you could figure out how to use it properly. So it's a typical automation tool. Our products are butter knife, and even if you hold it with the wrong end, you can still get the job done. So that's kind of the way I present our products. So we're trying to solve the big problem, which means the first mile connectivity. Just we want to connect to the machine and provide data. We do all kinds of things. Mostly we're gateways, but we've also done things like the bottom right picture is the Bellagio Hotel in Las Vegas. I have a box in there in the water that makes the Allen Bradley drives look like the old drives from the 1970s. So because they didn't want to change their control system to talk Ethernet IP, so we just put a box in to convert it. So we do some really cool projects. This is what I'm working on now, and Dave, you'll recognize this. From take factory floor data, have all these kind of drivers to get all that data, model it, format it, aggregate it, put it in a database, and publish it to all these kinds of applications. We don't want to do anything with the data other than present it in a way that can be easily consumed by these things. So I'm pretty excited about this. Also be releasing a network diagnostic tool that I found that I think is pretty cool. So I'm working on a lot of fun, that I think are really fun stuff. The data hub you can have modules to run the data hub, or modules for systems that have to be certified like Ethernet IP, and systems that need hardware like EtherCAT.
And it's industry 4.0 ready because it is called a data hub. So that's one of the things that it has to be.
Right.
It's got to be a hub of some kind.
So my tagline is going to be no hassle licensing, no hassle communications, no hassle combining, harmonizing data, no hassle delivery in containers. So I think that'll be pretty cool. And so that's it. So there's my contact information if anybody needs me. Thanks a lot for listening to me. It wasn't, a lot of this stuff is not, I haven't done this presentation and talked about OPC and OPC UA in about 6 or 7 years. So thanks for putting up with a little bit of the stumbling.
Well, no, I think it's important to understand, how did we get here? Where did this come from? And I think a lot of it's just we take it as face value as just that's the way it is. But as I mentioned, there's a podcast that I listen to. It's Cautionary Tales, Tim Harford. One of them at the episode he talked about was in the exploration to Antarctica and how scurvy came back. And one of the lines or comments he made in there is that if we don't understand why something works, we risk confusing ourselves back to ignorance. And I think that is so true in modern manufacturing and technologies. We just don't understand why things work. And so we risk confusing ourselves into ignorance of doing things that, well, that's just how we've done it. And we think that's what we have to do. I have to cut the ends off my ham before I can cook it because that's what my mother always did. But the reason why, it's because it wouldn't fit in her pan otherwise. It's very true. So even though it's been a number of years, John, it's still very relevant. We have to understand why. So we can then think about how do we want to move things going forward. I see this a lot, and people will talk about how ISA 95 is not relevant, and I don't think you understand what actually it was intended to do. We just were informed by it. We interpret it in a way that it wasn't meant to be interpreted.
It's the mark of being a professional is to understand the history of your profession. I have known almost no salespeople, almost no marketing people. One engineer I've ever known that could tell me who actually created the first Claude. No, I forgot his name. Claude, the guy that wrote the first spec in 1946 on industrial communications. I can't remember his name now, but anyway, not many people know the name of that guy. And if you're a software person, you really should know him. I've actually even visited the statue in his hometown in northern Michigan.
I think this is a
Okay.
really good review, and I appreciate it, John. This is really, really awesome. Getting the history aspect of things as well as your opinions in the discussion. It's eye-opening for me because I'm getting deeper into these topics. It's really helpful.
Yeah, it's Claude Shannon. Claude Shannon was the guy that in 1946, they were still, they were still doing things like trying to just use more and more power to get a bigger and bigger signal. And he's the guy that actually came up with the theory of communications that you could transfer data without all of those issues. I wrote a newsletter article or a blog post about Claude Shannon. So it's something that everybody should know. But the point is that, you really need to understand why we are where we are and what's been tried in the past. And you can't just say that the past is not relevant, because past is very relevant, especially in manufacturing where things move so slowly. I mean, like I was talking about before, Kimberly-Clark's got, they spend $75 million to build a diaper machine. They want to run it for 50 years. When I was at Lipton Tea has the tea machine, the basic, tea machine they're using is from 1919. I mean, the process of tea hasn't changed in 3,000 years. You still take leaves in one side and powder comes out the other. Is that ever going to change?
Mm-hmm. Yeah, absolutely. Yeah, and I'm a big believer in that. If you don't know how we got here, then it doesn't. I mean, it informs you. It's the tension of what got us here won't get us there, but you also have to understand where did we come from, because we have to make sure we stay within that limit of what are we known for, what's the core competency. It's there. So there's a lot of things that are always in tension with each other. It's we need you to innovate, but we need you to be, we need to have some governance in there as well.
There's also a lot of technologies that failed before their time. If you don't look back at history, you can't revive things that really could be made better with today's technology.
Mm-hmm. There's a French expression that roughly translates it's wrong to be right too soon.
I've got some very non-traditional PLC programming methods that were influenced by a 80-year-old PLC guy who started on microcontrollers and what he was doing back in the day. By his standards, it was what he wanted to do in the 70s. But by today's standards, it's too modern and non-traditional. It was influenced by methods from the 70s.
Mm-hmm. Well, there's a lot of great stuff that came out of the 70s. So,
yeah.
Are you referring to yourself?
Well, that and disco.
Yeah.
Cool.
Good. Yeah, this is
Well,
awesome.
we can stop the recording and just keep talking about stuff in general, or we can all get on with our day. I guess I'll just go ahead. Is there anything more, John, that you wanted to present? Otherwise, I'll stop the recording.
No, stop the recording then. I forgot about it. That's right.